This is section 2.4 of the class notes, one-sided limits, and this is example 14. So we want to do parts A, B, and C here. We want to evaluate these limits by using the limit, this famous limit. The limit as theta approaches 0 of sine of theta over theta is equal to 1. So essentially we want to make sure that we get part of the limit into that form. Okay, and the idea here is that the argument of sine, the theta, has to be the same as what's below it, and then once these are the same, this could be 2 theta, that could be 2 theta, this could be 3 theta, that could be 3 theta, and so once these are the same, then as theta approaches 0, it could be the same as 3 theta approaching 0, so that doesn't matter here, but these guys got to be the same. The argument of a sine, this theta has to be the same as this theta. So when we first come down here, we look at the first example, part A, the limit as x approaches 0 of the sine of 2x over 5x. So what I need to do is extract the 2x here. So notice that I have the sine of 2x over 2x. Okay, so how did I get that? Well, notice that if I had my 5, there would be my 5x times 2. So since I'm really just multiplying the denominator by 2, I have to also multiply the numerator by 2 so I don't change the problem. Then I got my sine of theta, in this case, is 2x divided by theta, which is 2x. So these guys are the same. So then when I bring this constant 2/5 out in the front, the limit as x approaches 0 of the sine of 2x over 2x is automatically 1 by that value of this limit. So 2/5 times 1 is 2/5. In part B, we want to get it into the same idea, but here I have to first rewrite tangent of t and secant of 2t in terms of their sine or cosine descriptions. So we know that the tangent of t is sine of t over cosine t, and we know the secant, that should be 2t, sorry, secant of 2t is 1 over cosine of 2t, this should be cosine of 2t, divided by 3t. Okay, so the first thing I'll do is I'll go ahead and bring this 3 out in front, so I have 1/3 here. And then I have sine of t over this t, and then I still have 1, and this should have been cosine of t times cosine of 2t, actually, not cosine squared of t. So this should be cosine of t times cosine of 2t. I apologize for that mistake. Okay, bottom line is this guy, 1 over the cosine of 0. Cosine of 0 is 1 times cosine of 0 for 2t is also 1. So this is 1. The sine of t over t, these arguments are the same, so the limit as t goes to 0, that's also 1. So I have 1/3 times 1 times 1, which is 1/3. Okay, now the same thing I'm going to do in part C here. Again, I've got to work this into getting sine of x over x, or x over sine of x, by the way. It's the same thing. It doesn't matter which guy's on top or the bottom. The limit as x approaches 0 of sine x over x, or x over sine x, also approaches 0 is also 1. Okay, so just simplifying this, notice that in the numerator I can factor an x out, so I get x times the quantity 1 plus cosine of x. I still have sine x times cosine of x in the denominator. So I can put the x and the sine x together, and then that's multiplied by 1 plus cosine x over cosine x. So this is the same thing. This limit here, as x approaches 0 of x over sine x, is the same as whether it was sine x over x. It doesn't really matter. So this limit is 1. Here I plug in 0 for cosine, I get 1 plus the cosine of 0, which is 1, divided by the cosine of 0, which is 1. So this is all 1 plus 1, which is 2, over 1, so that's 2. So 1 times 2. So my answer is 2.